Alright, let's go. It's time for the self-test. I got Clear Obscure, so I'm going to play that. I guess today and tomorrow. I got 2 weeks or something to do it, so... Oh, fuck, I can't even do it next weekend, but I'll have the weekend after, so that'll... Oh, I just missed it. Isn't that... Okay, I'll get them later. It's fine. Alright. So, through 13.7 now. Feels good seeing this. I've covered every single topic through here. And I mean, I'll argue that that's half the whole page. So. Alright. Quiz me on all information covered in the following. LearnCPP.com. Chapters and sections. Please number the questions. Oh, I thought that was a little piece of fuzz. Piece of fuzz. Please number the questions in order and arrange them in the following. Excuse me. Please quiz me on the last 4 to 5 chapters. And for earlier, well, on the last 4 chapters, questions in order. Then randomize questions from the remaining earlier chapters. That way I can work backwards and focus on more recent, less familiar material. Then get a random exposure to earlier information. I'm not gonna say any shit like, oh, reinforcement learning, and then I'm gonna use the same thing. Same chat every time. Instead, I'm gonna say, do it this way. That way I'm exposed to everything still. That's it? Okay. Let's do it. Kind of want some music. Hasn't been hurting my understanding at all. This band is always pretty amazing. What was that? Oh, no. Yeah, this will be good. Cool. All right. What in the fuck am I hitting? Like hitting some sort of fuzz on my keyboard that's messing with my thumb. Okay. That's it. I'm not gonna ask anything. I'm just gonna let it do what it does. All right. 1. A struct. Struct is a compound type composed of members, which include functions, variables, and what other compound types? Oh, templates, huh? I think, aren't they called, isn't it, aren't they functions, variables, and templates? But, I mean, I would almost say that functions and templates are synonymous. They're just a little different. I would say that a template is a type of function with more modularity. Members of data members, i.e., they are data types perfect examples of compound data types, or they are perfect structs are a perfect example of a compound type, since they are objects that literally contain other fundamental and user-defined types. Oh, and not templates, and types. Like I could put an enum in a struct. Like a hero that has a standard string, or like a hero, or like character struct that contains a standard string name, and int age, etc. Excuse me, structs are a class, so all class features are, well, I don't know, by class. Meaning that class properties, they probably inherit many class properties, but maybe not some. Like public, private, perhaps? And I'm not even sure how that works. Is that the same as internal linkage? And external linkage? I'm not sure. Actually, I have no idea how public and private are, because that's really close to external and internal linkage. Okay, that's my best guess. Damn! Yo, I don't know this. I don't know this stuff. Oh no. It just did everything from every chapter. Okay, all right. A struct named monster. Struct monster. Members for type. Okay, so we need a standard string. We'll make it a const standard string name. Oh, well, yeah. Well, hold on. Yeah, well, maybe we leave it like this. And then it gets initialized once and can't be changed. And then in health. And then... Huh? With members for type. What are we talking about? Oh, monster type. Oh, okay. I think that's what it means. Enum, and we'll do enum class type. So it has the name. I guess we could say it like size. Small, medium, large. And print their details using a function. And we could have a function that returns a standard string view. Sorry. Okay, returning a standard string view, and it's called, well, there's name, there's health, and then there's get type as string. Or we could say print void print monster details, maybe. And I could say, yeah, standard string view, get type as string. Yeah, type monster type. Switch monster type. Case small. Case type small. Turn small. Case type medium. Turn medium. Case type large. Turn large. Default. Return invalid size. I guess I could have done type there, but it's not a big deal. So we could say monster properties. Name. Excuse me, we could say name, health, type, oh, that's what I should have done. Get type as string, type. Oh, oops, hold on. Oh, hold on, type. There's an enum class type, and we say type monster type monster type. Monster okay, and so I'll have the name Ethan. I'll have 100 health, and I'll have a type of monster type small. And then we can say Ethan dot, right, print monster details. Cool. Oops, hold. Declaration of monster type hides class member. We'll say this monster type. That way this is referring to this monster type, not this monster type. This is the actual. This is, I mean, it doesn't really matter in this case, but there is a name conflict. Name Ethan Small. Okay. And this should probably be const expression. That can't be. That's it. All right. 3. When should you pass a struct by value by const reference or const address? I haven't passed structs before. Assuming since they're class types, I'll assume they're expensive to copy. Therefore, we probably should avoid passing them by value, unless we're passing cheap data members by value. Should pass structs as not by const reference when we want to access or to read but not change their information in a function, and pass by reference if we want to change information by using the struct as an out or in-out parameter. Just like standard string, well, expensive types, like standard string. Normally, by standard string view instead of reference, but the idea is the same. And reference would be the gold standard if standard string view didn't exist. Convert an unscoped enumeration to a string and vice versa. We can switch on an unscoped enumeration value in a function to return a C style string literal for each case. That matches the unscoped, or that enumerator values in a default error case. To get an unscoped enumeration from a string, we can get the string from the user. We can extract a string from the user via standard character input and or operator extractions overloading, using if-else statement to compare string values to constant strings with values matching the enumerator names, and return the appropriate enumerator. Or lack of one is a standard optional T, with T being the enumeration type. That way, if the user string doesn't match an enum string value, can handle it. Or well, that way, this lets us condition or evaluate the optional, the standard optional as a condition, letting us know if the for no match, string was didn't match. 5. Hold on. Go back. Oh, wait, hold on. I got water. I'll be back. Think of my tooth. Don't like it. Toothpicks are great. Five. A scoped enumeration enum class A scoped enumerations enumerators do not implicitly convert to integers. So attempting to print them as is via standard character output will fail, since no operator will have this enum class as an operand. And scoped enumerators will end the enumerators of one enum class cannot be compared to another enum classes. They are type safe. We'd have to cast them to integers to compare them, unless the enumerators are of the same enum class type. Scoped enumerations enumerators are also not placed in the enumeration into the scope the enumeration is in. Excuse me, must access them by using the enum or via the scope resolution operator and the scoped enums scope, or via using enum declaration for shorthand use and less redundancy. Well, repetition. 6. Overload the operator, this guy, insertion operator, creating an operator, this insertion function that returns a standard output stream reference and takes a standard output stream reference and with the left operand and what do I and Well, if it's the struct, that's interesting. I was thinking this is going to be an enum. Well, I guess I could put the operator there. I don't know if I would put it within the struct or not. I don't think so. I think I would do standard character output and then print the struct. The struct references the right operand. And in the body, get the information and print them using the standard output stream reference object. Parameter. That way, operator insertion can be used for standard character output or standard character error, and the struct as operands and print according to the overloaded operator overload function. 7. I haven't done this yet, but I figure assume it takes the same process as an enum. Create a class template. Triad. Yeah, I don't know how to do a class template. What does that even mean? So it's a template object. So it's an object that stores 3 values of the same type and you pass it, or do you create it with the 3 objects? And you can call it by triad. And you can have one that stores, this triad stores 3 doubles and another that stores another and another stores another. How about, let's try it. Is it template, boom. How about class template? Type name T. Uh-oh. It already doesn't like it. It's already not happy. How about template class? Uh-oh. Class template type name T, and it takes... Oh, hold on. How about... Or how about... How about template type name T? Okay, so far so good. Maybe it's before this, so okay. And if I remove this, I think wouldn't it start complaining because it doesn't have a thing? Yeah, it doesn't have a it doesn't have a declaration to anything. Okay, this seems okay so far. A fucking gnat, man. And then how about we create a T called X, a TY, and a TZ. So far it's working, so far so good. Fuck. Damn, maybe not. What if it needs it to be like this? Nah, same issue. Damn. I don't know if it needed special syntax. Damn it. What if we do this and I do this? Down. Expects 0. No, but this is a... No, this is... It's thinking this is a fucking type. Or a function. Yeah, see? Maybe? No, it seems like it's okay. It seems like it's... a template... Oh, hold on. It says class T. I'm not sure. I haven't done class templates yet. I tried a template clause followed by... What if I try with a struct? Wait. Oh! Wish I could loop this. Now what if we did 3.2? No constructor? Bam! Now, what about a function template? How about a void called... How about we call it triad? Let me call it triad. Uh-oh, what are you complaining about? Yeah, it's just the void. Okay. Void print triad values. I mean, I guess I'll just call it print triad, sure. And then done. The fuck out of here. Bam. But now, what if we do a triad my test double? Fuck yeah, dude. Should have just cut and pasted, or cut and paste. 8. An L value is an object that is a variable with a persistent memory address. An R value is an unnamed object without a persistent memory address. Int X is an L value, while 5 is an R value. An L value reference. An L value reference to a non-const. Is there another nat? Can't tell. To a non-const L value. Okay. Non-const modifiable L value. It cannot refer to R values or non-modifiable L values. A const L value reference can refer to L values, modifiable or non-modifiable, and R values. It treats the object as non-modifiable and cannot be used to modify the object. The object. It's referent. And you want to put a period after here because the word is not referent period. It would make no sense to include a quote in the quote. The quote is something verbatim. And the word is not referent period. The word is referent. Pass large objects by const reference to access the value in, to directly access the value of the bound object instead of expensively copying it, like a we do this for standard strings and other large objects. Like we do for standard string, instead of expensively copying it. If the object needs to be modified by the function, we can pass it by reference. And if we don't need to or don't want to, well, if we don't need to modify it, passing by const reference is safer, since it cannot be modified via the reference. Excuse me. A pointer is an object that stores the memory address of another object of an L value. We can dereference a pointer to, well, we can reassign non-const pointers, pointers that aren't pointer to const, to point to other objects at will. can dereference pointers after evaluating them as a condition to confirm they aren't null. To get to access the value of the address they hold. Value at the address they hold. Of the object at the held address. Pointers can point to, this is, we can reside non-const pointers. Pointers to access or change the value of the object at the held address. You can't change the value if the object is const, meaning that the pointer is a pointer to const. Pointers let us cheaply pass large objects to functions by passing the address's value, not the object's. Similar to a pass by reference. However, non-const pointers can point it at other objects. Creating a greater chance for them to dangle than references, which can only be bound to one object and only dangle if that one object is destroyed before the reference is. A const pointer is initialize a pointer to an int via int pointer int p. XP address of int object. Bro, I swear I'm feeling stuff. Am I just growing hair for once? Int pointer XP int object. Address of the int object. 12. A const pointer is a pointer that cannot be repointed or cannot be pointed at objects other objects after it is initialized. Pointer to const can be repointed, but cannot used to modify the value at the address. The object at the address. Const pointers can. Just for the one object they ever point to. Okay. Okay. 14. Standard optional, the class template that optionally holds a value. We can evaluate it as a condition to determine if it has value, or execute dot has value and access that value by dereferencing it via operator this guy, or, and I'm not going to call it dereferencing. Well, I guess I will, because it's probably the same thing for a pointer. So there's a value that it holds one value if you evaluate it as a condition, but then gives another if you evaluate the operator. So I wonder how that works, how you can set whether it implicitly converts to whether, or to a Boolean, if it holds value or not. Is it like overloading a condition operator? I'm not sure how that works. Or dot value. Yielding undefined behavior if or a thrown exception if accessed but empty, respectively. Yielding undefined behavior if not empty, if empty, or dot value yielding a thrown exception empty. This lets us serves as a solution to using sentinel values, which are hard to keep track of and may be impossible if all possible values are valid. $15. Wait, we're only doing the one output? Okay. 4 and 6. And we have references x now. We've incremented x via the reference, so it's 5 and 6. 5 and 6. But now it's 6 and 6. And then it's 7 and 6. 7, 6. 7, 6. X is 4. And y is 6. Then ref is bound to x, and x is incremented to 5 via ref, yielding 5 and 6. Then ref x is assigned y is 6 via ref, so 6 and 6. Then ref is incremented again, or well, then x is incremented again via ref, yielding 7 and 6. Type deduction works with pointers by dropping top level const from the pointee, dropping references and top level const from the pointee, i.e. deducing standard string from standard string pointer. Oh, well, hold on. Oh, it doesn't matter. deducing const standard string pointer const. Well, deducing const standard string pointer from const standard string pointer const. Standard string from const standard string reference, because it drops the reference and drops the const. Pointers, reference, and const? Oh, okay. It doesn't drop low level const, but it can convert low level const to top level const, and we'll drop it for references. On the pointees data type. A const expression function is one that evaluates at compile time if passed constant expression parameters and called in constant expression context. Excuse me. If those two if either of these criteria are false, it will evaluate at runtime. Regular functions are subject to the compiler's whims and probably usually evaluate at runtime unless the compiler decides to optimize them and evaluate them, or optimize and evaluate them at runtime. Const expression functions are evaluated at runtime if the function is not passed constant, or if arguments passed to a const to it are not constant expressions, or if the function is used. Dude, my U keeps falling off. Do I type a lot of U's? One. It's not even that common. There's 4 in 2 lines. It's like 2 per line. That's not even crazy. What if this is used in if the function is not used in a constant expression context? If it is passed constant expression arguments and used at compile time context, evaluates at compile time, yielding the optimization benefits we want from it. What? Oh, oops, hold. Cool. Const eval is a qualifier for a function that forces it to always evaluate at compile time, yielding a compiler error if it is unable to, like when passing it non-constant expression, or pressing it arguments that aren't constant expressions. Alternative, well, in contrast, constant expression functions only optionally evaluate at compile time, but as a bonus, can still evaluate at runtime if needed when pass non-constant arguments that aren't constant expressions, or when used in a content or in non-constant expression context. Both types of functions yield compiler errors when initializing constant expression values with parameters, since their parameters are not treated as constant expressions. Like, for example, see, the fuck is happening here? Yep. Non-type template parameters. How do you ensure that a function can only be called? Use const eval. Function overloading involves creating multiple versions that use the same identifier in order to handle different argument types. Would do thing in X and Y. Would do thing double X double Y. Handles int arg calls. Handles double calls. Void do thing in X double Y. Delete. This allows int double calls. Well, I think that would still allow well, that would only work like that. I think we would still need void do thing double x int y. This allows double int calls. Since parameter order yields unique signatures. Can yield unique overloads and signatures. Function template is a function that the compiler generates separate versions of for each unique call to it. For each call with a unique combination of parameters. An order, and data type order, count, data type order, or count. Data type order, count, or unique combo of parameter types. Primary function template has likely has template types, placeholder types that the compiler replaces when generating these versions. Specializations or function instances yielding unique versions before execution that handle all separate calls, all unique function calls. Combinations of parameters. Alright, I'm gonna wash my hands and turn the fan on. Oh. Template, type name, T. T add TX TY. Turn X plus Y. Handles int and double calls. Could make a mixed version that casts to get common types. Or I guess not, it would already do that. If we said return double, then you'd have to do it both ways too. You'd have to say double int, return double int double. Oh, hold on. And 324. Function overload resolution is the process by which the compiler matches function overloads to calls to the identifier. Matches compares overloads and function calls by identifying the best matching overload to the call for each call. If it cannot determine the best match, because an implicit conversion has yielded multiple equally viable best matches, get a compiler error. A non-type template parameter, they type int double, well, int pointer reference constant expression parameter requires a constant expression argument that is defined in a template clause that requires a constant expression argument. It lets us non-type template parameters let us pass constant expressions to functions to then use the values in constant expressions, like initializing constant expression variables, passing them to const eval or const expression function. That's fine. Add equals delete after the signature. To disallow calls to the function. Template type name t int x. Void do thing tx or t y key thing use x as constant expression variable. Excuse me. Do this to prevent calls that would yield unwanted implicit conversions. And or ambiguous calls. Default arguments are values we can assign to function parameters if the parameters are not given arguments in a call. i.e. create double gravity, it's 9.8 in a function. To the right of all non-default of all parameters without default arguments. Otherwise, compiler won't know if we are omitting required parameters, omitting arguments for required parameters, or using putting default argument once or default argument once. And a function can use gravity to use 9.8. We can still override default arguments by including arguments for those parameters. Okay. How do they interact with function overloading? Oh, be careful with overloading because using a default argument means parameter means omitting an argument, which might yield ambiguous matches with functions that don't include the parameter that gets default argument. Put template this guy. It's a template continuation clause right above it, and explicitly specify the types of all placeholder types, like template int do thing int instead of t do thing t x t y. Add a function template that multiplies the value of any type by an integer. Okay. Template type name t. T multiply tx and y. Turn x times y. You might want to handle disallow calls with bool / character / short for t, since those yield narrowing conversions. Include function templates in header files because the compiler needs to see the full definition to generate specializations in every file the template is used. Statement is an individual instruction for the program terminated with semicolon. Except if statements if we're talking about a regular one, sure. Using an uninitialized variable yields undefined behavior since the value at the variable's address is unknown. If treating warnings as errors is off, this might crash the program yield unexpected behavior. No, or have no effect at all. Unsafe. A value returning function returns a value as a temporary object when evaluating its function call, and a void function returns nothing. Includes all code in a, well, let's see if we include it. The included header file. And a header guard prevents code inside it from being included in a file if it was already included in that file. Syntax error is a language mistake that the compiler will make, yielding a compiler error. A semantic error is a misunderstanding, or wrong assumption, yielding unexpected behavior, like decrementing an unsigned int below 0. Using a while loop instead of a do while, or vice versa. Using a postfix instead of prefix, increment operator, etc. Anything else that would say meaning mistake and not language mistake. Size of, I don't know what operator, but size of yields the size of an object or object's data type, or an object data type or array, or data type in bytes. Helps us identify how large types are on our implementation, or how large objects are, potentially for optimization or debugging purposes. Avoid unsigned integers for arithmetic, because subtraction might yield semantic underflow errors. I mean, that's really the only issue I see. I mean, they're safe for addition. I mean, they're more safe than fucking non-unsigned integers, signed integers, because they have way more room. But maybe it's weirder though, because if you increment a signed in too high, you get a negative value and you're like, whoa, that's totally wrong. Okay, I understand we overflowed it. But if it's an unsigned in and you overflow, you still get a positive number and you're like, why is it low? But I guess you kind of get the same understanding. A standard string view is an object that contains standard string contains is an expensive, or is a class instance of which, or objects of which are expensive to copy. Standard string view is also a class, or well, no, object that... How the fuck does a string view work? It views that, to me, functions similarly to a reference to a reference to const, where we can get a view of a string, C style string, standard string, or standard string view, to cheaply pass its information where needed. Please explain the exact processes underlying it and compare to pointers references. 39, operator precedence is the order that operators evaluate, like an order of operations. An order of operations. If we thought operator plus evaluated before operator multiplication, 3 plus 5 times 3 would be 21, not 36. Holy shit, 4 times 3 is 12 times 3? Oh, sorry, hold on. Not 15. Sorry, 12 plus 15, or 12 plus 3, not 7 times 3. Which is basically... sizable difference. Operator precedence. How the statement will execute operation by operation, letting us accurately predict the result. A compound statement is a statement that begins and ends with braces. This and ends with this, letting us execute multiple inside statements as one total statement, like for switch cases and, well, I guess not switch cases, but switch cases, and, loops, and if statements. Okay. Boom. Whoa, 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 whoa. Didn't even critique it. Hello? The fuck? No, 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 no. Bro, what in the fuck are you doing? Please evaluate my responses and respond. Okay. Structs are public by default, whereas class members are private by default. They can have functions and types. Structures not inherit key differences. Okay, access specifiers. I don't know about how that works yet. Code correct. Struct with an enum string and int. Cool. A member function. Yep. Enum class type should ideally be declared outside the struct if I want to use it elsewhere. Yeah. Oh wait, hold on. This is just extra. Okay. What pass my value on this cheat? Tiny structs. Okay, it makes sense. But then it's case by case. Okay. For string to enum. Oh wait, it's evaluating. Wait, what? Oh, okay. I forgot that I did work backwards like that. Yeah, I don't know how standard mapper on order map works. Scoped enums prevent implicit conversion to other types. Okay. Well, yeah, including integers. Yeah, it makes sense. Yep. And idiomatic. Good, good, good. Our values can have addresses, but we cannot bind them. Or hold on. Can have addresses, sure, but they're not persistent apparently. But you cannot bind regular value references to them. Well, I want to know why, but I think it's because they don't have persistent references, so they can't. They would dangle. Expensive. Cool, cool, cool. You can pointers to cons pointers to both. Yep. Yep. Cool. Correction. Hold on. Popping integers. Oh, whoops! I totally did that using pointers. So we would say, I'd pass address of this, boom, this, and then temp. Yeah, exactly. So we would have a little one. Yeah, that's cool. All right. Option of the value, step by step, clarification, drops top level, but keeps low level const on the pointy. Yeah, yeah, yeah. Well, I mean, there's no low level const. Low level const is only on the pointy. So yeah, I mean, yeah. Correct, correct. Cool, cool, cool. Could just return the graded value if you don't care about quality. Provided could use instant optional. Okay. Constant value forces compile time evaluation, correct. Default value, goody. Standard string is a non-owning view. It does not manage memory and receive to copy. How exactly does a standard string view work? Non-owning reference, such as those string, C style string, substring. Oh, here we go. It stores to, so it has a pointer to a const character and it has a size. Okay, so it's literally a pointer. You motherfucker, bro. It does not own it. So it's a pointer to it. And for some reason it's if this is it, how can it not change it? Is it, oh duh, because it's a const character pointer. Wait, bro, it's literally. Yeah, but that's the same as a reference. Well, yeah, if it's, wait, hold on. So if it's changed. Oh, because it's a const character pointer, meaning that it's bound to it. Well, hold on, it's a pointer though. And it can be reassigned. I think the pointer is that it's looking at one spot though. It's not looking at an object. Well, I mean, I guess that's true for a reference, true. I mean, if it gets fucked up. If it's destroyed or modified. Okay. How... if that's how it's actually defined, what's the point of the whole if the original string is, well, so it's a pointer to a character. That's the point. Excuse me. So there's a string and it's the pointer to a character, and I guess we can step through it. I don't know why it isn't just, so it's treating the whole thing as one character. Because if we have a standard string and I assign a standard string view to it, it's pointing to the whole thing like the whole thing's a character. And the point is that if it changes, then the value of the character that it's looking at is wrong. Okay, I think that's fine. That's good enough for today. Nice. Alright, that's going pretty fucking fast. I don't normally go that fast. Alright, somehow that's 6 hours today. I don't know how. That was easy peasy. And, are you fucking me? Player Obscure is still barely installed. Look at this. Look at how shit Microsoft is. Look at this. My computer is pretty freaking good. I haven't upgraded it in a long time, but look. Nothing. Nothing is being used or anything. This shitty ass app. I can't. I can. Oh, now I can. Bro, this fucking app is so terrible. I cannot. It's just so bad. All right, that's it. Done for today. More studying tomorrow. I'm getting better at studying for longer. So yeah, I think that's the strat. 3 hours every day on weekdays, and then 6 hours every day on weekends. I could continue, but I think there are diminishing returns, and this feels like a good spot for now. I think. I'm at a good rate. Maybe I increase it later on. I don't know. I do another thing, and we do 7.5 hours of studying, and that's 5 separate study sessions. So it's like 10-hour total studies. Okay.